So 7 raised to x plus 1 indeed, left 1. Perfect. Next. Great. Not yet. I'm not there yet. Yes, negative 7 raised to x plus 1. But this is not negative 7 raised to x plus 1. It's 7x raised to x plus 1 times negative 1. What is that? Very good. A reflection with respect to the x-axis. Perfect. Awesome. Final transformation in order of operations will be negative 7 raised to x plus 1 plus 49. What do I need to do? Up 49. Very good. So let's graph. You told me to graph, shift this graph left 1. So where does my pointer here go? Where is this going? Very good. 1 to the left. Awesome. So this is 7 raised to x plus 1. Now you told me to reflect. Where does my indicator go?
To negative 1.
Yes, it goes to negative 1, negative 1. And here's the graph. This is the graph of negative 7 raised to x plus 1. Perfect. Now, what is the horizontal asymptote of this graph? Very good. I have to shift it together with the graph. Or actually, I would have to shift the asymptote first before I shift the graph. So what do I do? Exactly. So the horizontal asymptote now, because I don't have enough space here, I'm going to say this is 49. So, of course, it's a dashed line. So y equals 49. And where does my point go? This one. Correct. So negative 1 comma 48 right here. Perfect. Awesome. Well done. So this is the graph of negative 7 raised to x plus 1 plus 49. So I will also ask you, for example, what is the range of this function? Negative infinity till? But does it go to infinity? It has a horizontal asymptote. To 49 indeed. Negative infinity to 49 and not 49. Very good. Awesome. Good problem. Okay. Next type of problem. Anything else you would like to go back to?
I don't have a specific problem for it, but summation notation.
Very good. Very good. I have plenty. They come from section 8.1. So here are the major topics here. We are given the general term and we're asked to find few terms. We can be given the recursive formula to find few terms. We can be given a summation notation to evaluate. We can be given a sum to change into a sigma notation. What kind of problem should I look for?
I'm sorry, could you repeat that real quick?
General term, recursive formula, factorial simplification, and the summation notation with different situations.
I think the last one.
Okay, very good. Good. So here is one problem, like 40, on page 752, in which we have a sum from I equals 0 through 4, from negative 1 raised to I plus 1 everything divided by I plus 1 and factorial. They want us to find the indicated sum. How many terms do I have to write before I add them up? When I is 0, when I is 1, when I is 2, when I is 3, when I is 4. From 0 to 4. How many terms? Good. So let's plug in 0. How much is 0 plus 1?
1.
So negative 1 raised to 1 is negative 1. How much is 0 plus 1? 1 factorial is 1. Plus, when I is 1, how much is 1 plus 1?
2.
Negative 1 to the second power.
1.
Good. 1 plus 1.
2.
2 factorial is 2. Plus, when I is 2, 2 plus 1.
3.
So negative 1 to the third is negative 1. 2 plus 1.
3.
3. 3 factorial is
6.
6. So this was 0, 1, 2. Now 3. When I is 3, 3 plus 1.
4.
Negative 1 to the fourth, 1. 3 plus 1.
4.
4 factorial, 24. Last one. When I is 4. 4 plus 1. Negative 1 to the fifth, negative 1. 4 plus 1. 5 factorial is 24 times 5.
120.
Very good. And we have to add them up. Let's do that. So we listed all 5 terms. Any questions on this? Is it clear? Okay.
Just substitute.
Just substitute, yes, from 0 till 4.
Okay.
Okay, so the first one is negative 1, and then plus 1/2 minus 1/6 plus 1 over 24 minus 1 over 20. And of course, the least common denominator will be 120. So 120 here, 60 here, 20 here, and 5 here. Negative 120 plus 60 minus 20 plus 5 minus 1. So this is 40. So this is 44, right? So it's 40 plus 4, 44. 120 minus 44, 76. So negative 76. Negative 76 over 120, and I have to try to simplify. If I simplify by 2, I get 38, 60. Again by 2, 19 over 30. Any other type, like let's say we're given a sum of terms and we want to condense it using the sigma notation.
Yeah, I think that's what I was looking at. 'Cause
Okay.
The one that really was confusing was 22 in the
Very good.
I think that's what you're referring to.
Yeah, perfect. Let's do that. Any questions on this? Any questions on this? Okay, so let's say 52 on 753, 1 over 9 plus 2 over 9 squared plus 3 over 9 cubed plus dot 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 plus n over 9 to the nth power. And we can condense this using the sigma notation. And we can use any index we want. We can use y, j, k, you pick. It's not important. Okay, so from k equals something till something, and then something like a general term that involves k. So that k goes from this to this. When k is this first number that you are going to tell me, we're going to get this. When k is the second one, we're going to get this. When k is the third, we're going to get this, and so on and so forth. Very good. Lower limit, this is the index. Lower limit, upper limit. Very good. That's We go to n, from k equals 1 to k equals n. And now what? From what? From so that when I plug in k equals 1, I get this. When I plug in k equals 2, I get this. When I plug in k equals 3, I get this.
K over 9 to K.
Very good. When k is 1, 1 over 9. When k is 2, 2 over 9 squared. When k is 3, 3 over 9 cubed. When k dot dot dot, when k is the last one, which is n, I get n over 9 to the nth power. Is this good enough? Is this good? Okay. Do we understand this? Okay. What else should we look at? We want to look at a recursive formula from the sequences. Anything else from the sequences? Okay, what about systems or Gauss-Jordan or?
Yeah, we can look at Gauss-Jordan.
Yes. So let's choose one. Gauss-Jordan is in 6.1. Okay. So let's look at 30. On page 631, 2x plus y equals z plus 1. 2x equals 1 plus 3y minus z. And x plus y plus, plus z, equals 4. I did reserve a room for any questions you may have on December the 8th at Arundel Mills, 401, from 11 till 12:30 p.m. So it will not be a review. You will come in with questions, and you will ask questions, and I will answer your questions.
What is the next test?
Tuesday. Yes, last test Tuesday, and the following Tuesday, the final.
Are we ever going to the final tonight?
I'll do anything you want me to. I would love to, but
Yeah.
So the first thing is to get into the proper form.
correct.
So x, y, z.
Yes, 2x plus y minus z equals 1. 2x minus 3y plus z equals 1. And x plus y plus z equals 4. So did you write this down? It's Saturday, December the 8th, Arundel Mills 401, 11 to 12. So now we are ready to write the augmented matrix. 2, 2, 1, 1, negative 3, 1, negative 1, 1, 1, 1, 1, 4. So the first step is always the same, and we cannot deviate from any of the steps. I need here to have a 1.
Divided by 2.
If I divide this by 2, I will be in trouble because I will have 1/2 and negative 1/2 and positive 1/2. I don't really want to work with 1/2.
Multiply by negative.
No.
You could swap the.
Yes.
Swap the
Yes. I will say row 1 becomes row 3 and row 3 becomes row 1. That's the easiest thing to do. So then the top is 1, 1, 1, and 4. 2, negative 3, 1, 1, and 2, 1, negative 1, 1. I recommend, if you'd like to come in early, that would be great. My previous class, my calculus class, has an exam as well. So you can come in anytime you want. You can start early. Now, I would leave, to tell you the truth, I will leave this problem at the end. Why? Because I don't want to get frustrated. It's so easy to make a mistake on Gauss Jordan. So that's why I swapped it, because it has a 1.
Oh, you said it was not right. I thought it was right.
That's okay. That's okay. Good. So now I will use this to eliminate the 2's. Only this number can allow us to, or helps us to eliminate this. Yes, so I have to multiply row 1 by -2 and add it to row 2, and row 1 by -2 and add it to row 3. Let's do this together. And I lost count. So this was 1, 2, 3. Let's do this together. Which row do I have to copy because it will not change? Yes, because I'm using it. Can't change at the same time when I use it. 1 times -2 plus 2. 1 times -2 minus 3. 1 times -2 plus 1. 4 times -2 plus 1. Awesome. Well done. Ugly, but that's it. It is what it is. 1 times -2 plus 2. 1 times -2 plus 1. I like it. 1 times -2 minus 1. Perfect. 4 times -2 plus 1.
-7.
Okay? Good. So we accomplished this. I will never go back. This is done. My next target is right here. I want this to be 1. What should I do to get this to be 1? I will be in trouble, because if I divide by -5, then this will be 1/5 and this will be 7/5. Shouldn't say in trouble, but I don't really want to do that. But if I multiply 5 by -5, I get -25.
So you can swap rows again.
Yes, but not with the first one. The first one is carved in stone. So I will swap, and at the same time, so let's say row 2 becomes row 3 and row 3 becomes row 2. And then I will divide both sides by -1 or multiply by -1. 0, -1, -3, -7, 0, -5, -1, -7. And I have to have 1, not -1. So I will say row 2 gets divided by -1. Are you with me? Okay. So then 1, 1, 1, 4, 0, 1, 3, 7, 0, -5, -1, -7. Which row I have to use now in order to eliminate this and this? Yes, I'm using row 2 and multiplying it by something to add it to row 1, and row 2 again multiply by something and add it to row 3. What do I multiply 1 by to add it here and get 0? What do I multiply 1 by to add it here and get 0? Of course. What do I multiply 1 by to add it here and get 0? Perfect. Okay, so notice something. Which row I have to copy now? Yes, 0, 1, 3, 7, and 1, 0. Notice one thing. I don't even look here. This is now fixed. carved in stone. I'm done. I don't even look there. Don't waste your time. 1 times negative 1 plus 1. 3 times negative 1 plus 1. 7 times negative 1 plus 4. That's it.
I have a question.
Sure.
I thought we were looking at rows going horizontally. Are we looking at them vertically? This way?
We are building everything vertically,
Okay.
but what we are doing is all horizontal,
Okay.
all on rows. So, very good question. One more time. We only have 3 operations called row operations.
Okay.
So we can swap, we can multiply or divide rows, swap rows, multiply or divide rows by a non-zero number, and the third one is multiply a row by a number and add the result to another. So nothing happens vertically. However, it's a very good question. The process step exactly.
Okay.
Yes.
I was confused.
It
I
is.
thought we were looking at it horizontally.
Everything is horizontal because all the 3 operations are row operations, not column operations.
Okay.
Very good question. Okay. So 1 times 5 minus 5. 3 times 5 minus 1. 7 times 5. 35 minus 7. 35 minus 7, 28. See, this is done. Don't even look at the first column and second column, because if I destroy something here, I'm not solving. I'm going backwards. Okay, where is my next step? Yes, what do I have to do to row 3? I want the 1. If I don't get the 1, I will not get the zeros. So that's my next step, exactly what I had here. I needed a 1 to get the zeros. I needed the 1 to get the zeros. If I don't get a 1 here, I cannot get the zeros. No, but I have to divide by 14. So one more time, the 3 operations are swapping rows, dividing or multiplying a row by a non-zero number, right? And the last one is the one which is more complicated, multiplying a row by a number and adding the result to another. Good. So that's the one before the last step, not the last step yet. 0, 0, 1, 2, 1, 0, 0, 1, 3, 7, negative 2, negative 3. Now I know what I have to multiply. Which row? Very good. By a number to add it to row 1 and by another number to add it to row 2. And now this is for sure the last step. Unless I made an error and I have to go back and start from scratch. I hope not. Which row do I have to copy? Correct. So now let's do this together. Oh, I forgot to ask you. 1, I multiply 1 and add it here to get 0. What do I multiply it by? I multiply 1 by something to add it here and get 0. Perfect. 1 times 2 minus 2. 2 times 2 minus 3. 1. 2 times 2 minus 3. 1 times negative 3 plus 3. 2 times negative 3 plus 7. Okay, maybe it's too nice to be true. So what do we expect the solution to be? Yes. Do I trust this? No. Nope, I don't either. I'm just hoping. 1, 1, 2, 1, 1, 2, 1, 1, 2. The last one is clear. 1 plus 1 plus 2 is clear. 2 plus 1, 3, minus 2, 1. Yes. 2 minus 3, negative 1, plus 2, 1. Lucky me. I'll say yes. Do we feel a little bit better about the method now? It's yes, that's true. However, would you agree that once you see it, you can go back? Once it's clear, it's clear.
Yeah.
Good. So now please choose the next problem. Anything you want. Is there anything else for this test if we want to review? Anything else? Okay, a system of inequalities. Linear or non-linear? Linear? Okay. Very good. The non-linear is more complicated because, okay, but you want linear.
Maybe we can do both.
Okay, let's do non-linear then. And this is section 5.5. I don't know if we did 55. If we did, just stop me. On page 600, in which we have x squared plus y squared less than 16, and we have y greater than or equal to 2 to the x. So I don't change anything, or I shouldn't say that. I don't change the inequality into an equation, but I need to write the equation because I have to graph it first. So the first equation, can anyone dictate the first equation? It's right there.
X squared plus y squared. Less than.
Equation.
Oh, equals.
That's it. I need to write this first. Good. What is it?
It's a circle.
It's a circle with a center at,
0.
very good, 0, 0. And the radius? Awesome. Well done. Good. Do I graph it as a solid curve? No, because there is no equal symbol. Great job. Great job. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You know it's not going to be perfect. I don't expect that. This is only x squared plus y squared equals 16. It divides the entire plane into two regions, the inside and the outside. And of course, I'm going to pick the inside with 0, 0. 0, 0. 0 less than 16?
Yes.
Yes, it is. Since 0 is less than 16, I'm going to have to shade in the inside. Not the points on the circumference, though. Now I repeat with the second equation. Can anyone give us the second equation?
Y to the.
Y equals 2 raised to x. Good. What type of function is it?
Exponential.
Awesome. Increasing or decreasing on all its domain?
Increase.
Awesome, because the base is greater than 1. Great. Where does it cross the y-axis? Always. Yes, yes. Solid or not?
Solid.
Solid indeed. Here it is. Perfect. So now I see that this graph divides the entire plane into two regions. One above, because this goes on forever, and one below. Say it again.
My brain keeps thinking that it has to be like positive or negative in order for it to be, in order for it to.
I'm only checking whether the inequality is true. I'm not checking whether it's positive or negative.
I don't know, my brain keeps thinking.
That's okay. So just remember, we have to pick a point and see whether this inequality is true, like we did here. We are not looking for positive or negative. But I know what you're thinking about. You're thinking about solving polynomial inequalities in which we use a table. It's a different story, but it has only one variable. But this has two variables. We cannot do that.
Okay.
Good. So I pick the origin, remembering that I'm testing the bottom territory. So I put 0, 0, greater than or equal to, how much is 2 raised to 0? Right. So now, is 0 greater than or equal to 1? If you say true, I will shade in the bottom region. If you say false, then I will shade in the above region. Yes, it's false, so I have to shade in this. All this blue territory, I forgot, sorry, my mistake. The red territory, everything that is red inside represents x squared plus y squared less than 16. What I see on the circumference is the equation. What I see inside is the inequality. So now all the blue region is y greater than or equal to 2 to the x. I'm not interested in red. I'm not interested in blue. But I'm interested in both at the same time, where I see red and blue. Is there a region where I see red and blue? Yes. So therefore, all points on the curve and everything in between, but not points on the circumference. Not. So what does the yellow region represent? Solutions to both. To the entire system, in other words.
Just out of curiosity.
Yes.
I assume we wouldn't be doing that, but is there a way of finding like an equation for that solution?
No. What we really do with this is linear programming.
Okay.
Yeah. But it has to have linear inequalities.
Okay.
Right. Good. Anything else that you would like to go back to? Logarithmic equations, exponential equations, word problems.
Expanding logarithms.
Very good.
Expanding-
Okay, very good. That is in section 4.4. No, forgive me, it's in section 4.3. So you want expanding and condensing.
Yeah.
Very good. So let's take a look. Let's look at 69 on page 501, in which we have log x plus log x squared minus 1 minus log 7 minus log x plus 1. We're asked to condense. So one more time, log x plus log of x squared minus 1 minus log 7 minus log x plus 1. So now, if you remember what we discussed when we went over this, every log with positive in front, its quantity will come from the top. Any log with negative in front, its quantity will come from the bottom. And then you can do it in one step. You don't have to. So log, what do I have at the top? X. Yes. Awesome. And the denominator?
7x plus 1.
Correct. Awesome. Now, I see that I can simplify a little bit. If I factor, if I remember, was the first day, our first handout, x squared minus 1. If I factor this, I will simplify. So this is log x plus 1, x minus 1 over 7 times x plus 1. And I can simplify one of these because they are the same. We can only simplify factors. That's why I need to factor. So log x minus 1 over 7 is the simplified form. And this was condensing from 4 logs into 1. So now let's look at expanding. Let's say 35. Any questions on this problem?
How would it be altered if instead of minus log of x plus 1, it was plus?
Yes.
Would
So
that go to the top?
yes.
Okay.
So if I have this plus, then these 3 quantities will go to the top, and only this one will go to the bottom.
Okay, so every quantity that's being subtracted goes to the bottom.
Yes.
And then they're
Because of the rule, yes, the quotient rule. So log of A over B is log A minus log b. Any questions? Okay, so let's look at 35. Log base 5 of the cube root of x squared y over 25. So this time we are given basically this piece, and we want to come up with these. That's the idea. Now, on this problem, we're given 4 logs. We condense it into 1. Now we are given 1, and we want to expand using the 3 properties of the log. Where is the starting point here? And it must be, and there is no other way, but
The cube root.
exactly. I can't do anything before I eliminate that cube root. What power is the cube root? 1 over 3, right? So please remember, x cubed and the cube root of x cannot be the same. So this is a quantity raised to the 3rd power. This is a quantity raised to power 1/3. Good. Awesome. So then 1/3 goes in front, and this is log base 5 of x squared y over 25. So now I know what to expect. How many factors I see? 1, 2, 3. How many of those will have negative in front?
1.
Exactly. So then I have log base 5 of x squared and plus log base 5 of y and minus log base 5 of 25. Yes, I have to take this power. This is the only function that allows us to do that. I have to distribute 1/3, but I have to try and simplify this. Yes, it is. So remember, the most important concept here is that a log equation can be converted into an exponential one. 5 raised to which power is 25? Yes. 5 squared is 25, so that will be replaced by 2. So the final form will be 2/3 log base 5 of x plus 1/3 log base 5 of y minus 2/3. See if you have any questions on this. So that was about condensing and expanding. So please remember the cube root is power 1/3. Anything else that you would like to review? I'm hoping that you are quickly, after you say I'm prepared for this test, you will redo test 1 and test 2 with solutions, please, as many times as possible. Is there anything else from this test that we would like to go back to? Anything else from this test?
Suppose graphic logs.
To graph logs?
Yeah.
Very good. Perfect. Do we have what problem, or I choose?
I'm just looking at the one in the packet. But
Very good.
Log, just log base of x plus 4.
Very good. That's it?
Yeah.
Okay. So first, I highly recommend finding the domain of this function. How do I find the domain of this function? I have to write something, very important, solve it, that will give me the domain.
Would that be x plus 4 equals 0?
No. Strictly greater than 0.
Okay.
Log does not exist if you apply it to 0 or 1, 0 or less. So only from 0 to infinity. Good. So then the domain will be -4 to infinity. Now I want to graph the base function. What is the base function here?
This,
Say it again.
not this.
Very good. Log, common log, base 10 in other words, log base 10 of x or common log x. Very good. Is it an increasing function or a decreasing function on all its domain?
Increasing.
Yes. Every time the base is greater than 1, both functions, the exponential and log, must be increasing. Where does it cross the x-axis? The pure log function. The pure exponential crosses at 0, 1.
1, 0.
Exactly. It has to be reversed. So this is log x. What is its vertical asymptote?
That's the y-axis, so x equals 0.
Perfect. I already know where I should shift it to because I already determined the domain. But I have to shift the vertical asymptote first. Where do I shift this asymptote to? Excellent. Because that's where the domain is. X equals -4. Now my indicator, where does it go? That's all I need to look at. Very good, right here. Awesome. You guys can teach this class. And if you're asked, what about the range? Yes. Log is a function with restrictions for x, but y is anything. Good. Any other problem? Anything else?
Everything else I feel pretty confident on. It's mostly the compounding interests.
Okay, do we need any of that or no? Anyone else? Would you like to go back to the previous tests? Since our test is going to be on Tuesday, when we review for the final on Thursday, I'm hoping that we don't need to go back to this. Maybe just go back to the other 2 tests. Because this should be already, yes, unless you have questions, of course, when I return your test. Of course, we'll go back. Are we thinking of anything else?
Real quick in my
Yes, yes.
So with a logistic growth formula, one of the
Yes.
questions,
Yes.
it asks about the number of people initially affected.
Yes. Every time we're asked about initially, time is 0.
Yeah. So you plug in 0.
Yeah, and then it's asking you, I don't know, 10 weeks later, and you plug in 10. When it comes to the limiting size of the population, it means what is the horizontal asymptote of the function? If x or time goes by and goes by and goes by and goes by. So I would plug in 40, 50, 60, 100, and you'll always see it's the numerator.
Okay. So the limiting size for for example, a population.
Yes, you're going to put in 10 weeks, 50 weeks, 100 weeks, and you'll see the answer will always be the top number that you have.
Yeah, because that's just the maximum number of people.
Correct, which is the entire community. Now, this has an assumption.
Yeah.
And the assumption is that there are no visitors.
Yeah, it's static.
Because if you have visitors, then, the number of many may increase. But the formula does not take that into account.
Yeah, so in reality, the top would usually be its own equation. monotone expression
Yeah.
for population growth.
So it is, the assumption is that, there are no visitors. What are we doing next? I'll let you decide.